Hi everyone, myself Jithendra. I am from Department of ECE in Vtech Multitech Dr. Rangarajan Dr.Sakunthala Engineering College. My project title is Electricity Generation from Industrial Waste Heat Energy using Solid State Semiconductor, and my teammate is S. Jayraj, and our pod guide is Mr. R. Suresh Kumar ME. Let's get into the abstract. Electricity is generated from thermoelectricity using partial cells. Producing electricity is one of the competitions for things in the world. For the coming year, in the same circumstance, we are wasting a lot of energy by generating and converting one energy to another, such as many waste industries that waste heat. The Seebeck effect, the Pilcher effect, the Thomson effect, and Joule heating, as well as with the applications, components used to figure of merit, quality improvement, and subtract types. In addition, performance simulation examples such as Cosmol and ANSYS computational fluid flow are examined. And the next topic, objective to design TEG. TEG stands thermoelectricity generator using partial cells, utilizing industrial waste heat to generate the energy to produce electricity with a partial cell by employing Seebeck, which maintains the varying temperatures on a separate side. And the existing system is using the TEG module. Many of them were investigated and the average output was found to be 2-3 watts. Previous designs are created by a slight stove at the undersurface and little dielectric material inside the bottom and thus top of the device. A load must be placed across thermoelectric material to convert the Seebeck voltage into electricity, which can result in an electric current. The difference in temperature is smaller. The production of energy density is also smaller. And the working mechanism is it's intended to work with the light fire and aluminum cooling panels through the regular water or by freezing water. We need to link the Peltier, the cell, to the hot surfaces of the machines in the industries to generate energy for industrial appliances. We could cool the top with water or coolant oil, but we use coolant oil since we need to adjust the temperature on both sides of the TEG module. So, depending on the load, we can link series or parallel to enhance the voltage or current. The metal bat keeps the steam at the bottom while the ice water cools the top aluminum so that the Seebeck effect produces a quantity of electricity on this module. The unit of energy is proportional to temperature differential, and this is a diagram of TEG cell geometry and mesh in ANSYS. The prototype output has a good DC voltage, which is ideal for small devices such as mobile chargers, power banks, headphone chargers, emergency lab chargers, mini LED boards, and mini DC fans. The inverter works on the principle of converting DC voltage into pulse DC, which is a step toward converting sinus waveform, after which the heartbeat is converted into a sine wave using an oscillator IC, and the output of that sine wave is allowed to view as an input of the step-up transformer, allowing us to use appliances such as bulbs, chargers, adapters, set-top box adapters, laptop chargers, and so on. And the implementation is the prototype. We proved that we can produce electricity from industrial waste heat energy employing a solid state semiconductor. Now we able to produce electricity from the prototype, so it's the starting of saving the globe from waste heat energy. For the ultimate demo, the prototype output, which might switch LED board, mini inverter board, DC motor pump, USB charger setup. For the first startup, needs small battery power to pump the water. To start out the method after start process, we would like not need battery to run the module the heat, and the water is enough for to run the module. And this is the hardware implementation. And the block diagram is the waste heat which is taken from the industries are passed through the semiconductor, which is applied with water cooling. With the help of these particles, we pass through the current and LED charger. With LED charger, we passes through the electricity with the help of this particles inverter. With the inverter, we converts the inverter into the AC voltage. And this is a brief abbreviation of the block diagram. First, we taken the fire and the waste heat from the industries. In the middle of the box, cooler semiconductor heat exchanger is the Peltier cell, which is supplied by both heat and cool. In the outside, we take the cool water supply and the motor pump to generate cool and heat, and it forms a forward biased diode which is forward to setup controller, and it fills the capacitor which is forward towards the voltage regulator with the help of BMS battery, and we get the output voltage. With the output voltage, we use some of the mobile charger, emergency lamp, DC fan, power bank, charger, and etc.
This is our final output, where we can see that there is a candles by the bottom and there is a heat sink above the candles, which will be used as the heat source, and above that there is a aluminum chamber that will store the cold water. The cold water is supplied from there, and there is a suction motor which will sucks all the water, and the water is transported to that aluminum cold water chamber, due to which there is a temperature gradient at below. There is a hot chamber, and above that is a cold chamber. Between those things, as we have Peltier cells in between, due to the Seebeck effect, the electricity will be produced, which can be evident by the glowing light, and this can be controlled by the switches, and there is a inverter to store if there is any excess current is produced, which can be transferred to the AC main supply if in case is there any necessary water power supply needs are there, which can be even supplied to a small households or streetlights in the industrial area.
And its advantages: it's simple to assemble in industries in any position, reduces the economic machine, and thus enhances the productivity of the industry life. Less expensive, recycle the heat waste. And the applications: automobiles, industrial purpose, storing in batteries, power supply to offices and houses. And the conclusion and future scope: the study assessed the expected output of advanced TE materials is such applications based on engineering design assumptions. The study discovered large technical obstacles that must be overcome before TEGs can be widely acknowledged as a practical choice for recovering energy from toxic waste heat emissions in a reasonable and cost-effective manner. Thermoelectric generator research may be needed to specialize in developing thermoelectric materials that could endure higher temperature from a variety of industrial heat sources while still being cost effective and supplying superior performance. And these are the references which we taken from before. Thank you so much.